Hello everyone. This class we begin to learn the electrical machinery course. The electrical machinery course is a core professional course in the automation technology major of power systems in vocational colleges. This course aims to help students familiarize themselves with power transformers, synchronous generators, asynchronous motors, and other basic structures of various electric machines. Understand the working principles, electromagnetic processes, and operational performance of various machines. Master the installation and maintenance procedures and quality requirements, thereby laying a solid foundation for students to engage in electrical operation and maintenance work. This course is designed according to the teaching, learning, and doing integrated model, which organizes learning scenarios and work tasks to align the teaching process with the production process, the teaching content with the work content, and the teaching evaluation with professional evaluation. This design ensures that students acquire the necessary knowledge and skills in the operation and maintenance of electric machines, comply with the students' cognitive rules and professional growth patterns. The learning method for this course is to understand the basic structures of various electric machines, familiarize oneself with the working principles of various machines, master basic theories, basic concepts, and operational characteristics. Remember that current can generate a magnetic field, and a changing magnetic field can induce an electromotive force in a conductor. They interact and restrict each other. When analyzing electric machine problems, focus on the main factors and ignore minor ones. Strengthen practice. Identify problems and deficiencies during practice. Next, we will start learning the introduction part of the electrical machinery course. The electrical machinery course. 1. Definition of electric machine. An electric machine is a mechanical device that uses interaction between electricity and magnetism to achieve energy conversion between mechanical energy and electrical energy. Electric machines are important electrical equipment in power system operation. They mainly include power transformers, synchronous generators, and asynchronous motors. A transformer is a static electric machine that transforms a certain grade of AC voltage and current into another grade of AC voltage and current with the same frequency. In power systems, transformers are divided into step-up transformers and step-down transformers. according to their functions. Step-up transformers input low voltage and output high voltage. Step-down transformers input high voltage and output low voltage. Transformers realize the conversion of electrical energy. A synchronous machine is a type of AC rotating machine. Its rotor speed is always the same as the speed of the stator's rotating magnetic field. Therefore, it's called a synchronous machine. Synchronous machines are mainly used as generators. Synchronous generators convert mechanical energy into electrical energy and are the main equipment in modern power generation. Asynchronous machines are mainly used as motors. They are widely used in industrial, agricultural production, and daily life. In the power grid load, asynchronous motors consume more than 60% of the electricity. The stator is energized and the rotor current is obtained through electromagnetic induction. Therefore, they are also called induction motors. Compared with other motors, a synchronous motor have advantages such as simple structure, durability, and ease of manufacture. 2. Role of electric machines in the power system. Electric machines are important equipment in the power system. The production, transmission, distribution, and use of electrical energy are inseparable from electric machines. Most power plants use synchronous machines as generator to reduce the energy loss and voltage drop in long-distance transmission. Set-up transformers are used to raise the voltage and adopt high voltage transmission. The higher the voltage level, the more significant the advantages. In various electricity consumption areas, step-down transformers are needed to lower the voltage for safe use of electrical energy. In the power system, the main loads are electric motors. 3. Materials used in electric machines. Since electric machines work through the interaction of electricity and magnetism, they must contain electrical and magnetic circuits. 1. Conductive materials. Use conductors with low resistivity, such as copper and aluminum, to wind coils and form electrical circuits. 2. Magnetic materials. Use ferromagnetic materials, such as silicon steel sheets and cast steel, to form magnetic circuits. 3. Insulating materials. Use insulating materials between conductors and various components, such as polyester varnish, epoxy resin, glass fiber, mica, etc. 4. Structural materials. Use components that integrate electricity and magnetism into one organic body. 4. Differences between electrical and magnetic circuits. 1. In handling electrical circuits, electric fields are generally not involved. In handling magnetic circuits, magnetic fields are indispensable, often involving the distribution of air gap magnetic density in electric machines. 2. In handling electrical circuits, leakage current is generally not considered. In handling magnetic circuits, leakage flux is generally considered, and there is no absolute magnetic insulator. Most magnetic flux is concentrated in the arrow core, with a small part of leakage flux outside the core. 3. The electrical circuit's resistance R is considered an ideal linear element, while in the magnetic circuit, magnetic resistance R sub m of the iron core depends on the magnetic density B in the magnetic circuit. The larger the magnetic density B, the greater the magnetic resistance R sub m. 4. In the electrical circuits, there is a loss with the current. In the magnetic circuits, there is a loss only when the magnetic flux changes. Basic law of magnetic circuits. Ohm's law of magnetic circuits. The formula is F equals Ni minus phi R sub m times F equals Ni minus phi times R sub m. F is the magneto-motive force, also called ampere turns A. N is the number of coil turns. I is the coil current, and phi is the magnetic flux. And R sub m is the magnetic resistance in the magnetic circuit. The positive direction of the current and the magnetic flux conforms to the right-hand square rule. Second, Faraday's law of electromagnetic induction. 1. Content. When the magnetic flux in a conductor or coil changes, an electromotive force is induced in the conductor or coil. The magnitude of the induced electromotive force is proportional to the rate of change of the magnetic flux. 2. The mathematical expression is given by the formula as E equals minus N d phi over dt. Explanation. The negative sign in the formula reflects the direction of the induced electromotive force relative to the change in magnetic flux, which is a mathematical representation of Lenz's law. When the magnetic flux increases, is taken as negative. When the magnetic flux decreases, is taken as positive. In this class, we introduced the introduction part of the electrical machinery course. I hope everyone does more practice after class to consolidate the knowledge of this section. This class ends here. Thank you, everyone.